Hi, I'm Paulo, and I'm going to discuss the turning circle of ships and ship handling importance and definitions. So, a ship's maneuvering characteristics define its ability of turning or checking course, keeping and stopping distance. When a vessel fitted with a fixed right-hand propeller, she would benefit from the transverse thrust effect, and a turning circle in general will be quicker and tighter when turning to port to starboard. The longer the ship generally, the greater the turning circle. So the resulting steering effect will decide the final diameter, with a clearance between the rudder and hull having a major influence. The smaller the clearance between the rudder hull, the more effective the turning action. So the following factors will affect the rate of turn and size of turning circle. First is the structural design and length of the vessel. Second is draught and trim of vessel. Third is size and motive power of mine machinery. Next is the distribution and stowage of cargo. Next is even keel or carrying a list. Then position of turning in relation to the available depth of water. And lastly is the amount of rudder angle required to complete the turn.
Good day everyone, I'm Cadet Sanchez Leon Ecolo. Today, I will discuss and enumerate of proper procedure in mooring and anchoring. Mooring and unmooring operations provide the circumstances for potential serious accidents. There is no doubt that this duty requires a good technique initially in lifting the heavy eye of the rope, followed by a good pulling technique. Care must be taken, therefore, with the laying out of heavy mooring ropes and wire ropes and hawsers. Seafarers involved in mooring operation should be given additional instruction on the specific equipment and mooring configuration used on the vessel. This should include, but may not be limited to, the types of winches and windlass and their operation, the location of emergency stop buttons, the type of ropes and or wires used, the location and use of rollers, dollies, and leads. Crew should make sure that there are enough manpower available to the task safely. Personnel should never stand in the bright of a rope or near a rope under tension, and they should treat ropes on drums and bollard with the utmost care. Detailed familiarization should take place to all new joining seafarers regarding the new installation, use and hazards related to permanent and loose mooring equipment. Based on the risk assessment, appropriate control measures should be put in place.
Compare the turning circle in ballasted condition to the turning circle in loaded condition. The longer the ship generally, the greater the turning circle. The type of rudder and the resulting steering effect will decide the final diameter, with the clearance between rudder and hull having a major influence. The smaller the clearance between rudder and the hull, more effective the turning action. So turning circle diameter, or TCD, there will be two TCD of different diameters. This is due to the direction of the rotation of the propeller for most single screw merchant ships. The propeller rotates in a clockwise direction when viewed from aft to forward part of the ship. It does make a difference to the turning circle diameter, or TCD. So ship model tests and ship trials have shown that the TCD does not change if this trial is run at speeds less than full speed. If these trials had been carried out in shallow waters, the TCD could have been double that measured in deep water conditions. So this is the image of a normal full loaded condition with maximum speed.
I am Cadet Segundo Vincent Cassidy. Compare the turning circle and ballasted condition to the turning circle and loaded condition. Merchant ships usually turn in a circle having a diameter of about 3 to 4 times the length between perpendicular or LBP. The larger the rudder, the smaller will be the turning circle or the diameter or TCD. During the TCD maneuver, the ship will experience the transfer, advance, drift angles, and angle of heel. The maximum angle of heel must be recorded if the ship has port rudder helm. This final angle of heel will be to starboard and vice versa. Again, this is the centrifugal force acting on the ship's hull. This maneuver is carried out with the ship's shape at full speed and rudder helm set at 35 degrees. The ship is turned completely to 360 degrees with, say, starboard rudder helm and then with the port rudder helm. Turning circle diameter there will be two TCD of different diameters. This is due to the direction of the rotation of the propeller. For most single crew merchant ships, the propeller rotates in clockwise direction when viewed from aft to forward part of the ship. It thus makes sense are different to the turning circle diameter or TCD. It should be observed in figure that at the beginning of the port turning maneuver, the ship turns initially to starboard. There are reasons for this. Force acting on the rudders itself, it will cause this move at first at the starboard. Larger centrifugal force acting on the ship's hull will then cause the vessel to move the ship on a course to a port as shown in this diagram. Ship model tests and ship trials have shown that the TCD does not change if this trial is run at speed less than full speed. If these trials had been carried out in shallow waters, the TCD could have been double the measured in deep water conditions.
Good day everyone, I am Cadet Vinluan. Today we're gonna discuss about the importance of ship's turning circle in ship handling. So let's start. The ship handler, for instance, should be aware of how long it will take for a vessel to come stop in the water from a full ahead position or how far the vessel will advance in a turn. Turning circles and stopping distance or speed trials provide such essential information to those that control today's ships. Next is, what is the effect of turning circle to ship handling and maneuvering? If a small rudder angle is employed, a large turning circle will result with a little loss of speed. However, when a large rudder angle is employed, then although a tighter turning circle may be experienced, this will be accompanied by a loss of speed. As you can see here in the example image, turning circle maneuver can be explained briefly as: first, it is ensured that the vessel is heading towards a straight line with a steady approach speed. Then, rudder is turned in the specific direction. For starboard, turn rudder is turned towards starboard side. So for summary, here are the legends. Turning circle is when a vessel is made to turn under a continuous helm through 360 degrees. It will follow a roughly circular track called turning circle. Next, advance. It is the distance traveled by ship along original course line when she alter her course through 360 degrees. Transfer. It is the distance traveled by the ship measured from original course line to the point when she altered her course by 90 degrees. Tactical diameter. It is the distance traveled by the ship measured from original course line to the point when she altered her course by 180 degrees. And lastly, drift angle. It is the angle between the ship fore and aft line and tangent drawn to the turning circle. That's all. Thank you.
Good day, sir. I am Cadet Bertusio Stephen Y. And today, I am going to tackle about the compare the turning circle in ballasted condition to the turning circle in loaded condition. So, in some circumstances, the turning circle as a measure of turning capacity in fully loaded condition is significantly bigger than that in the ballast condition, or the turning circle in trim by stern condition is significantly larger than in even keel condition. So a further point to mention is that the sea trial test for a new ship is typically conducted in ballast condition. So that's all, sir. Thank you.
Hi, good day. So I am reporting about compare the turning circle and ballasted condition to the turning circle and loaded condition. Deployment and monitoring of moorings. The master should ensure that mooring operations, including interaction with tags, are carried out carefully. The following items are appropriately addressed: suitable planning and supervision, proper communication, competency of personnel, sufficient members of the mooring teams, familiarity with any specific shore requirements relating to shore moorings, passing traffic, and tidal or weather conditions. Merchant ships usually turn in circle, having a diameter of about 3 to 4 times the length between perpendiculars LBP. The larger the rudder, the smaller will be the turning circle diameter TCD. During the TCD maneuver, the ship will experience transfer, advanced drift angles, and angle of heel. The maximum angle of heel must be recorded. If the ship has port rudder helm, this final angle of heel will be to starboard and vice versa. Again, this is due to centrifugal forces acting in the ship. This maneuver is carried out with the ship at full speed and rudder helm set at 35 degrees. The ship is turned completely through 360 degrees, which say starboard rudder helm and then with port rudder helm. Turning circle diameter. There will be two preceding of different diameters. This is due to the direction of the rotation of the propeller. For most single crew merchant ships, the propeller rotates in clockwise direction, which viewed from aft to forward part of the ship. It does make a difference to the turning circle diameter, CCD. And this is a diagram about normal full loaded condition with maximum rudder angle. Full sea speed 104 RPM. Meter diameter, and then advance 6.28 miles. Then TCD or tactical diameter transfer at 90 degrees 180 degrees maximum transfer, plus drift angle, path of the ship's approach 0 helm. Note the initial movement to starboard.